I'm glad that you could come to this presentation. I'm going to hurt up a few heads because most of us have been building our data centers like we were building for something in the past. Today, we have to definitely change the way that we go about building our data centers. Today, I'll talk about some of the challenges, some of the things that we have to do to actually build out a data center. Your compute, your storage, your networking, that is your LAN, your WAN, and of course, we have to talk about IT resiliency, and I'll give you some key takeaways. You may be wondering why this slide is up, but most of you have realized from a long time ago that the Amazons of this world, the Microsofts of this world, the Googles of this world have been having traditional IT on their dinner plate for a long time now. Cloud services are going to be the future. How do you compete against enterprises that are resilient, scalable, and are profitable because they're operating at a lower total cost of ownership? Back in the 1990s, we started out with servers directly attached to storage. One of the things that happened with that is that applications were few and the business requirements were not that complex. As we move towards the 2000s, we find that virtualization came into play and the physical hardware was then abstracted from the application layer. With that, we ended up with a scale-out architecture for our applications, but we were limited by a scale-up architecture for our storage. Most of us today have SANs. The first time I heard that term was back in the late 80s. Not to date myself, but it was back in the late 80s. And storage was designed before virtualization, which came in 2000. So with that, it really does not understand the world of virtualization. So how can we build modern data centers with technology that is almost 30 years old? What happened with the virtualization layer? In order to be compatible with the storage era network, storage services had to be built in to the virtualization layer in order to translate between what we call virtual disk and, in the storage world, LUNs. One of the biggest problems that we have with traditional IT infrastructure is that we have complexity at every step. The first thing that happens within an organization is that we say, how do we plan for the next 5 years? How much capacity do we have to buy? When you look at it that way, you're trying to guesstimate the future when business is dynamic and agile. The two just don't go together. We heard from a customer who bought some storage array. And the first thing that they said to us was, it gets shipped, it first has to settle for 2 days, we can't touch it, before we install it. And when it comes to installation, it takes weeks to get storage array networks up and running. Management. At each layer, we have a different management network or management network interface. We have the layer to manage the virtualization, we have the layer to manage the servers, we have the layer to manage the storage, and we have the layer to manage the storage fabric itself. Too much complexity, and that is why we spend our weekends and nights trying to figure out how do we manage this environment for the business and keep it running. Scale. When it comes to scaling storage, one of the first things that most people say to me is, I can add disk. I can add some flash. I can add some hard drive, spinning disk. The biggest problems that they face, though, is that when they do, the limited IOPS that they have with the storage controllers, because it's just two, sometimes it's active-active, sometimes it's active-passive, is now being shared across all the virtual servers that are now distributed in infrastructure. So therefore, each and every server is now getting less and less IOPS, even though you have more capacity. So therefore, you have a bottleneck, your storage controllers. And of course, support. I know you have this problem, because in the support world, you have to first call the application support specialist or the vendor. Then you call VMware or Microsoft, or Hyper-V. Then if they can't solve the problem, then you go to the hardware guys. And if they can't solve the problem, then you go to the storage guys. And then when all of them get together, they say, guess what? It's just not my fault. So customer, you're on your own. So the challenges with the existing architecture, inherent complexity. Just take a look at that. How many of you can actually see your data center in that picture? You don't have to show any hands. But inefficient silos, we're talking about we have a set of servers to run one set of applications, another set of servers to run another set of applications, and none of them talk to each other. Unpredictable scaling. Have you ever tried to scale up your applications within your existing data center? I guarantee you that is not a trivial exercise. Multiple points of failure. We have visited some customers, and when we go into their data center, and we said, well, you know, a data center is supposed to be resilient, it's supposed to be scalable and everything. And we said, okay, why don't we take this server out of commission? They said, no, don't touch that, don't touch that. Because everything is fragile, everything seems to be a point of failure, whether it's a storage array, whether it's the network or otherwise. Space and power inefficiency. Of course, most of our servers today are like old fridges. They burn a whole lot of current. And of course, they take up a whole lot of rack space. And over-provisioning, we always want to buy for the next 5 years when we don't know what the next 5 years will bring. So is there a better way? We have to follow in the footsteps of those that lead. Those that lead are the major companies that offer us something that we call web scale. That is the Googles of this world, the Microsoft, the Facebooks, the Amazons, and of course, you don't know these names, but you may. But these are from the East, Baidu, Alibaba, Tencent, and guess what? There's even another person in this world that gets it, that you either get with it or you have to keep trying. Now, how do we go about solving this problem? I know most of you may have purchased a Lego set for your kids, but I can tell you, the buildings of the modern data center is in this diagram. Legos are small building blocks. What if you could build your data center from just small building blocks? You could mix and match colors. You had unlimited scalability. You could design anything that you want. And you could start small and grow, pay as you grow. You had no restrictions. Between generations, they could actually work with each other. How does your data center work today? I assure you, the concept of Legos will become very important with that. How do we build it? Web scale engineering. One of the things that the Googles and the Microsofts of this world don't have is what we call brand equity or brand affiliation. Modern data centers are built using off-the-shelf x86 servers. Intel makes most of the motherboards, most of the memory is Intel and Micron and those guys. The hard drives, same Intel and so forth. So therefore, when you are stuck in this branded for life type mentality, what you're doing is limiting your options and limiting the amount of money that you have to actually spend on your data center. All intelligence is in the software. So if you abstract everything that is physical and you put the intelligence in the software, then what do you have? Something that is programmable. And if it's programmable, that means you can add services without changing the underlying infrastructure. Scale-out architecture. Just like Legos, you can add one at a time, but yet benefit from future innovations in technology. Self-healing systems. No more waking up out of your bed at 1 a.m. because the system went down or some component went down. It was designed to fail, and it was designed to heal itself if something happened. Rich automation and analytics. Management is a headache, and if management is a headache, how do you deal with it? Automate routine tasks and leave the more complex tasks to the human to deal with. So we're going to look to simplify the infrastructure stack. What if you took compute, storage area network, and the storage, and you compressed it into a building block? And then you deploy that building block one by one within your data center. So you have a few at first, and then you actually scale up to thousands. That means an SMB can actually implement the modern data center. It's not out of reach because you can start with a minimum amount of blocks, then you can move to thousands. What if you could run all your workloads on the same platform? I think you get the idea of a modern data center. Let us look at networking. Back in the day, a decade ago, maybe a decade and a half ago, it's an industry with mainframe type mentality. So when you talk about the modern data center, you're talking about the compute, you're talking about the networking, and of course you're talking about certain attributes like resiliency. Today, it's still the same thing, except that boxes are a bit smaller. But we have the same problems. 20 million lines of code in a router, whether it be whatever brand it may be. Operating a network is expensive. Most of it is actually, half of it is actually in operating the network. And whenever there's a problem, it's usually an operator error because it's complex to manage. Few people can innovate. There's no layer upon which you can have innovation. In the cloud world, the reasons why you have companies like Netflix and you have companies like Yahoo and others is because others can innovate on top. That is what you need in your data center, that your business can innovate on top of your infrastructure. So imagine if your network was where you separated the control plane from the data plane. The data plane is where packets are forwarded. It's dumb. It doesn't have much intelligence. It gets its intelligence from the control plane. And above that control plane, you have innovation because all the network functions can actually be implemented at that layer. What you have here, ladies and gentlemen, is what we call software-defined networking in a nutshell. Let us now move to the WAN. Most of us design our WANs like all the services that we serve to our employees are in our data center. Branches connect to headquarters in a hub and spoke manner. That was when you didn't have Office 365, Salesforce, and all those other services being consumed by the organization. So MPLS, while it's good, reliable, predictable, the bad about it is rigid, you have no control, and of course it's expensive. Our reality today is that it's at least twice as expensive as ordinary broadband. DIA, that is. So we're coming from the 80s where we had lease lines. We went to the 90s where we had frame relay. In 2000 came MPLS. We are now near to 2020. Are we still going to build our WANs the same way? I say no. The current state of the WAN. When you visit most organizations, the WAN has an active link, then it has a backup link. And on one occasion, we actually went to one customer and he said, Undel, come and look at this magnificent thing. We have an MPLS and we have our internet connection. And whenever something happens to my MPLS, I fail over. So I said, okay, all right, so let us plug out the MPLS. He said, no, 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 no. When that happens, I have to actually get onto my computer and switch some IP addresses and move over. I said, but that's not resilience. How can you do that when you're trying to operate a business 24/7? How can you do that when people actually work on weekends and anything can happen when you're not here? That has to change. What if you could use ordinary internet connections to augment your MPLS? And you could augment your MPLS with any type of internet connection. It could be cable, it could be DSL, it could even be LTE. What if you could switch carriers, meaning that you could mix and match carriers as you want? So what you're doing is having carrier independence. What if you could simplify branch connectivity by deploying in minutes rather than months? I think most of you have experience that deploying a branch takes weeks. Now, with zero-touch provisioning, you can actually deploy a branch in minutes. And of course, WANs were made to serve applications to users. So with that, you're talking about how can I get LAN-like performance over my WAN? You can actually do that today. So SD-WAN is where it all comes together. So the tenets of a modern data center is that it's software-defined and it's cloud-inspired. You can build a data center today that has all the attributes that a Google data center, Facebook, and so forth has, but with privacy and control. Modern data centers are simple, scalable, and efficient. No single points of failure, distributed everything, scale-out architecture, and of course, last but not least, IT resiliency. The data center of the future will live in the cloud. That's a very profound statement, but it's a very true statement. According to IDC, in 2020, there will be no clouds. This is how businesses will operate in the future, meaning that there'll be no distinction between private and public. There'll be just IT infrastructure. The future of the data center is software-defined. If you're not building software-defined data centers today, going into 2020 and into the next decade, you're putting your careers, I may say, in jeopardy, as well as the success of your business. Business is IT, and it depends on it more than ever. Sometimes the business people say that, yeah, we can do without IT. No, they can't. They cannot do without IT. But what they will do is change out IT in terms of the leadership of IT. So I say this, that the IT leadership needs to rethink the conventional data center. And the best infrastructure is that which you cannot see, meaning that it is an infrastructure that allows you to operate without headaches, without pains, and without interruptions. Thank you very much, ladies and gentlemen. Building out the modern data center is actually twofold. Some of the services you'll actually run within your data center. Some of the other services you'll actually run in other data centers. So you will have a mixture of CapEx and OpEx. Some services that you'll run in other data centers, Microsoft Exchange, which is your email. Your website most likely will be hosted off-premise. And of course, a lot of the security services that you receive for your data center will be done off-premise because you don't want to invite the hackers onto the premise and then you fight them there, you fight them in the cloud. While within the data center that is on-prem, you actually have a CapEx. And in terms of the legacy infrastructure versus the modern infrastructure, because you're not buying those extra layers. Storage area networks, that is a thing of the past. The storage array actually is removed, 30-year-old technology. And all you have is a simple x86 server with software layer that gives a distributed control as well as management. And with that, what you'll find is that if you're not branded for life, meaning that if you're not paying the brand tax, then your ROI is actually in the hundreds of percentages. When I say hundreds of percentages, you're talking about buying ordinary servers, putting a layer of software that has intelligence in it, and running that, and it runs all your workloads. So therefore, hundreds of percent. And I kid you not, I say hundreds of percent, I mean hundreds of percent. That's how dramatic it is. And that is why the Googles of this world, the Amazons of this world, they actually started out building their data centers like we do. They got a storage area network and so forth, but it could not scale, it could not meet their business demands. And of course, as you know with those guys, cost is everything. So therefore, it could not meet their cost efficiency parameters. So they had to do it differently. They had to change, now we have to change. Any other questions in terms of a career path? I can tell you. The specialists in the room, whether you be a storage administrator, whether you be a hypervisor administrator, whether you be a hardware administrator, that job is going to change in the next 10 to 20 years. Some of you will still be around doing this stuff, but I can tell you it will change to being a generalist. You have to know how everything operates.